In this video, we're going to look at graphing a system of inequalities. It is going to look a lot like the systems of graphing lines when we had an equal sign, just a little bit of a twist on it for inequalities. So with this, we're going to need to fill in a couple of these things up here. I'm just going to write them out. You can copy them down, and then we will talk about why these make sense. All right, if you need to, you can pause the video to get those down, but we're going to go ahead and start graphing these. So treat these like you would the equations. So if I look at this, and I'm going to put this equation in the blue. So with this equation, I've got a plus 5 to start, so I'll go up 1, 2, 3, 4, 5. And then my slope says go down 3 over 2. And I'm going to do it a couple times just to make sure I get a good shape of a line, because we're going to get things to cross. We don't want the intersection point, but I want enough points so that I can get a nice extended shape of my line that is pretty accurate. Then I'm going to go ahead and graph the other one here. We'll do this one in orange. So starting at minus 3, 1, 2, 3. Then this says go up 1 over 2. Up 1 over 2. We actually do get a nice intersection point here. That might not always happen with these. However, one thing I forgot to mention with this first line is that we have to be careful based on the inequality sign about what kind of line we're going to put. So because this had a line underneath, because it's solid, because it has an aspect in its equation, or in its equation here that has an equal sign, we want a solid line. But if I look at this orange equation here, I don't see the line underneath. That means that we don't want it to be equal, and we actually are going to want a dashed line instead. This indicates that it being equal is a problem. So with this here, we want a dashed line anytime there's a greater than or a less than, and it does not share the or equal to part. Then we got to worry about, well, what's the solution? If I told you that we're not going to care about an intersection point, we want to find where there is an overlapping region. So where is there going to be some overlap? Now, how would we create some overlap? And a region means it's going to be a whole entire area. Well, the greater than less thans also tell us more than just what kind of line. It'll tell us whether we want a solid line or a dashed line. That's one thing. But we also know if we want things to be bigger or smaller. That's why we wrote some words like above and below. So with this, I'm going to take a look at the blue line and say, all right, it says y is less than. So less than we see is below. Things that are smaller, below, the low numbers are smaller, below. So below is going to be in this direction of the line. But if I look at this equation, or this inequality here, I've got greater than. Greater than, I want to be bigger, I want to be above. So I'm putting these arrows on the end to help me figure out where are the areas that count. So if I look at this section right here has a double arrow. It's saying this is a good direction for the blue, it's a good direction for the orange. So that's the overlapping region. When it works for both at the same time, this is the region we care about. that this part I shaded in yellow all the way up to the line, all the way up to our inequalities that we graphed. For the rest of the grid, this counts, this is an answer. That's why we don't care so much about the intersection point anymore, because it's not just one point that's in common, it's a whole region now. So we're going to repeat this just a couple more times to make sure we got this. Number two, we'll do this one in blue. Start at plus 4. And then with this, the negative 2, maybe you want an over 1, but down to right 1. Down to right 1. We got a couple good points there. Nope, I apologize. That looks like I made a mistake. I'm going to fix that real quick. All right, so I whited it out to fix it here. So 4 is actually up here, down 2 over 1, down 2 over 1. I see that. Maybe put some in the other direction, some down 2s over 1s in reverse. So up 2 left 1, up 2 left 1, up 2 left 1. Got some good points there. I've got the line underneath. That's why I'm going through with a solid line. So we got inequality number 1 here, inequality number 2. X is greater than negative 3. So this is not diagonal. It's not an mx plus b. So we got to remember, is this horizontal or is it vertical? Well, x equals were vertical. So I want a vertical line at negative 3 for x. So I'll go to x, negative 1, negative 2, negative 3, and I'm going to put a vertical line. But I want this to be dashed. And I want it dashed because, again, this says no line underneath cannot be equal. So we want a dashed line. Now let's think what arrows are going to help us out here. So greater than are greater than numbers for this to the right or to the left. Well, bigger numbers in the x direction are off to the right. So I want to think to the right. Then I want to look at this, say less than, above or below. So less than is below the line. So I want it to generally be going down. And I see now that the arrows are pointing in towards each other in this middle section. So this is the region that counts. This is going to be my answer, this whole region. Last type of thing we'll talk about in the video here is number 4. Number 4 here, you'll see the couple different types. You'll see the mx plus b, but then this double inequality. We're going to talk about that. So mx plus b, one will go up 5. 1, 2, 3, 4, 5. Up 1 over 2. Up 1 over 2. Up 1 over 2. I'm still going to recommend that for the first equation you're doing, dang it, I made a mistake again. I forgot that it's negative. I'll get some whiteout. Be right. All right, there's the whiteout. Forgot the negative. We're going down 1, right 2. Down 1, right 2. Down 1, right 2. Recommendation, do this until on the first line in both directions until you have them all. Because you don't this one's a little bit easier to predict, but you don't know where the crossing point's going to be. You want to see them cross, but you don't care if it's at a nice point or not. So doing the first one in blue again, the second one here in orange. Now, the x is in the middle. It is trapped in between the 3 and the 7. So that means I'm going to want to put one up at 3 and one up at 7. But again, this is an x, so it is vertical. at 3, and at 7. Two different lines, two inequality symbols, two lines. So over at 3, 1, 2, 3. Now I've got the line underneath again, so I'm going to put a solid line. 7, so 1, 2, 3, 4, 5, 6, 7. Put the line up there. And when I am looking at something like this, we could say that x is trapped between 3 and 7, meaning it's stuck between here. So I'm stuck between these two lines, and then I have to decide if I'm going to be stuck in the middle. I'm stuck in between these lines, and I look at the blue, less than or equal to, less than, below. I want to be below the line. I want to be under this line, but between these. That is going to leave us with this section. This right here in the yellow, all right there, that is what we're going to be with for our overlapping region for the answer to our systems of inequalities. Let me know if you got questions.